Today students, we shall be doing two component system, that is eutectics, congruent and incongruent melting points, lead silver system, ferric chloride water system, sodium potassium system. Today we shall be doing eutectics, congruent and incongruent melting points, lead silver system. So the types of two component system involving solid liquid equilibrium. So we have three types of two component systems involving solid liquid equilibrium. Type 1 is the two components do not react with each other but simply mix with each other in the molten state or in the solution. In type 1, the two components do not react with each other but simply mix with each other in the molten state or in the solution. Examples here are lead silver system and potassium iodide water system. In type 2, the components react to form a compound with congruent melting point. That is, the compound is stable up to its melting point. Here in type 2, components react to form a compound with congruent melting point. That is, the compound is stable up to its melting point. For example, ferric chloride water system. In type 3, components react to form a compound with incongruent melting point. That is, here the compound formed does not remain stable up to the melting point. In type 2, components react to form a compound with congruent melting point, that is, the compound is stable up to its melting point, whereas in type 3, the compound formed is going to be with incongruent melting point, that is, the compound formed does not remain stable up to the melting point. Coming to eutectics. Eutectic mixture. Let us first know what is an eutectic mixture. A liquid mixture of two components which has the lowest freezing point compared to all other liquid mixture is called a eutectic mixture. Mind it, here a liquid mixture of two components which has the lowest freezing point compared to all the other liquid mixture is called a eutectic mixture. This mixture freezes out completely at constant temperature and on freezing gives the two components as solid phases in the same proportion in which they were present in the liquid phase. Here, the temperature corresponds to the eutectic point is called eutectic temperature. This is always lower than the melting point of either the component. Here students, in eutectic mixture, the liquid mixture of the two components is going to freeze at the lowest freezing point, and beyond this one, it is not going to attain a lowest temperature, and at a particular temperature, it is going to attain a lowest temperature at a definite composition. Here, the two components are going to freeze out at the same composition as it was present in the liquid. And the lowest temperature which is attained here is called as the eutectic temperature. And eutectic temperature is always lower than the melting point of either the component. For example, when we consider bismuth-cadmium system, considering the bismuth-cadmium system, the eutectic mixture, the bismuth-cadmium system where the eutectic mixture contains 60% by mass of bismuth and 40% by mass of cadmium melts at 144 degrees Celsius. Here students, 60% by mass of bismuth and 40% by mass of cadmium melts at 144 degrees Celsius, which is lower than the melting point of bismuth, which has a melting point of 271 degrees Celsius, and that of cadmium is 321 degrees Celsius. The melting point of cadmium is 321 degrees Celsius. The melting point of bismuth is 271 degrees Celsius. But the eutectic mixture containing 60% by mass of bismuth and 40% by mass of cadmium melts at much lower temperature, that is 144 degrees Celsius. This mixture of 60% by mass of bismuth and 40% by mass of cadmium is called a eutectic mixture. Coming to another example, lead silver system. The lead silver system, the eutectic mixture contains 2.6% by mass of silver and 97.4% by mass of lead. This mixture containing 2.6% by mass of silver and 97.4% mass of lead melts at 303 degrees Celsius, which is lower than the melting point separately of silver, which is 961 degrees Celsius, and that of lead is 327 degrees Celsius. But the eutectic temperature for the mixture containing 2.6% silver and 97.4% lead is 303 degrees Celsius, and 303 degrees Celsius is the eutectic temperature for lead silver system containing the composition of 2.6% silver and 97.4% lead. Next is congruent and incongruent melting points. Coming to congruent melting point, systems in which the two components react to form a compound which is stable up to its melting point. Incongruent melting point, systems in which two components react to form a compound which is stable up to its melting point. At melting point, it melts to give a liquid of the same composition as that of the solid compound. Here at the melting point, it melts to give a liquid of the same composition as that of the solid compound. The compound formed is said to have a congruent melting point. Here, the example here is ferric chloride water system. In incongruent melting point, systems in which two pure components react to form compound that does not remain stable up to its melting point. On heating, it starts decomposing before the melting point to give a new solid phase and a solution with composition different from that of solid phase. Here, students, the two pure components react to form a compound that does not remain stable up to its melting point. In fact, on the other hand, it starts to decompose before the melting point to give a new solid phase and a solution with composition different from that of solid phase. When this happens, the compound is said to undergo transition or peritectic reaction. Here, what is happening? The compound is undergoing a transition or peritectic reaction and is said to have incongruent melting point. And the example here is sodium sulfate water system. Today, we shall deal with lead silver system. This lead silver system has two components and four phases. Remember, the system lead silver system is an example for two components and it has four phases. The four phases are solid silver, solid lead, solution of molten silver and lead, and vapor. So here I am having the phase diagram for lead silver system. Here in lead silver system is a condensed system with three phases. Though it is going to be four phases, but here it is a condensed system with three phases. In such a case, pressure has no effect on the system because it is condensed system. Pressure has no effect on the system. Thus, only the two other variables are considered. Pressure is not considered. Only the variables which are considered are temperature and concentration. The phase diagram for lead silver system consists of two curves AC and BC. A eutectic point, three areas. One area is ACB, area below AC and area below BC. Coming to the curve AC. AC curve is even called as the freezing point curve for silver. AC curve is called as the freezing point curve for silver. A represents the freezing point or the melting point of silver. Pure silver melts at 961 degrees Celsius. And the curve AC shows that the lead, on addition of lead, what happens? The melting point is going to lower along the curve AC. The phase in equilibrium along AC are solid silver and solution of silver and lead. Here it is going to have, on this point, it is going to have the phase which is present is going to be in equilibrium are solid silver and a solution of silver and lead. On applying the reduced phase rule, which gives us F dash is equal to C minus P plus 2. As pressure is neglected, it is going to be reduced phase rule, that is F dash will be equal to C minus P plus 2. Because it is a two component system, it is going to be 2, and on this curve I will be having two phases. One is solid silver and a solution of silver and lead. So it is going to be 2 plus 1. Thus a system of lead silver is going to be monovariant along the curve AC. Similarly, the curve BC is the freezing point curve of lead. The curve BC is the freezing point curve for lead. Pure lead melts at 327 degrees Celsius. On addition of silver, the melting point is lowered. The phase in equilibrium along BC is solid lead, because here it is solid lead and a solution. The system here also is going to be a monovariant. The two curves AC and BC meet at a point C, and this point is called as the eutectic point. The curves AC and BC intersect at a point C, which is called as a eutectic point. Eutectic means melting. The point C has the lowest temperature at which the liquid can exist in equilibrium with solid silver and lead. Here the three phases, that is solid silver, solid lead and the solution are in equilibrium at this. Here it is solid silver, here solid lead and the solution are going to be in equilibrium. On applying the reduced phase rule, it is going to be 3 component system, 2 component system, 3 phases plus 1. So at this point is going to be univariant. So this is going to be the point with the composition 97.5% lead and 2.5% silver are fixed. The temperature above the eutectic point is raised. If I am going to raise the temperature just above it, the solid phase of silver or lead disappears, and if it is cooled below it, the solid silver lead, where the solution phase is going to be here, the solution phase is not going to exist. The area above the curve ACB. This region represents the single phase system of a solution of silver and lead. This is going to be a solution of molten silver and lead, and it is going to be bivariant when I apply reduced phase rule. Any point above this area ACB is going to be bivariant. Likewise, the area below AC represents the phase silver plus solution. Here it is going to represent silver plus solution, while that below BC is going to represent lead plus the solution. The area below the temperature, 303 degrees Celsius represents silver plus solid lead. Here it is going to represent silver plus solid lead. All the areas have 2 phases and 1 degree of freedom. Here it is going to be again univariant. So students, today we have done lead silver system. In the next class we shall be doing, that is, ferric chloride water system. Okay, thank you.